So let's do the solution. Then what did they give us? They've given us Ti plus 4 plus 1 electron gives Ti plus 3. Electrode potentials are given, right? So SCP stands for standard electrode potential. Next, iron also is given. First of all, when such questions are given, remember what should you analyze? Here it is accepting electron, right? So when something is this is accepting electron, and it's becoming, see here, 1 electron added, becoming Ti plus 3. That means acquiring electron is what it is called, reduction potential. Remember that first important thing, acquiring electron is called reduction potential. Okay, done. So what is it measured in? This is measured in volts, basically measured in volts, remember. So this concept is clear, I think. Now one more logic which you should remember, right? A solution with, always remember, they asked me predict whether Ti plus 4 species can be used to oxidize this acid. So I'm giving you a clue that will be useful. A solution with higher reduction potential, remember, a solution with higher reduction. So this here, this is accepting electron, so this is reduction potential. Now one more thing, a solution with higher reduction potential than species means this solution, if it is higher reduction potential than the species, what will it do? It has a tendency to gain electrons. Remember this, it has a tendency to gain electrons. From where? From the new species. This will have a tendency to gain electron from new species. Okay, remember this. So when something is trying to gain electrons, what will happen? This species will undergo, or it will get reduced, and this species will undergo, or it will get oxidized. Remember, understand. Once again, acquiring electrons is reduction potential. When something reduction potential is high, that means it's going to, that solution with higher Rp than other species, it will have start tendency to gain electrons. When it is gaining electrons in the new species, what will happen? It gets reduced and the new species gets oxidized. Okay, now let us come back and see the question. They said Ti plus 3 or Ti plus 4 species, can it be used to oxidize Fe plus 2? Let's see. So basically Ti plus 4 by plus 3, what happened? Yeah, it cannot be reduced. Why? Because here I said it should be a higher Rp, then it is reduced. But here, does it have higher Rp than this? It is not having higher Rp, no, it's having lower Rp. So what is the concept? You should simply write in the answer. Let me take a, okay, here only I'll write. You can just write. So because Ti plus 4 doesn't have higher reduction potential, so you write, so Ti plus 4 by Ti plus 3. What will you write? It cannot be reduced in comparison to Fe plus 3 by plus 2. Hope this is clear, students. So if it is higher, it will get reduced and oxidized. Okay, now they said, can it be oxidized? It cannot be. See here, because it has lower reduction potential, right? So this is the question. Now let's come back and do one more question which is there here. Right. What did they give me? They said based on the data, arrange Fe plus 2, Mn plus 2, Cr plus 2 in increasing order of the stability of plus 2 oxidation state. Okay. So first important thing, they have given 3 values. What is important? What is the 2 marks question here? Important thing is arranging order is a half mark and writing the reason is 1 mark. Okay, no, writing, yeah, because earlier one it was 1.5 mark question, the earlier one. So it was this one. This is a 3 marks question, isn't it? So this first one, this particular thing is 1 mark and this is half mark. Now here in this, the first reason would be 1 mark and the second would be half mark, right? So first of all, they said arrange the following in the increasing order of the stability of plus 2 oxidation state. Remember one clue. whenever there is a reduction potential, why is it reduction potential? From Cr plus 3 it's gaining electron, Mn plus 3 gaining electron, Fe plus 3 plus 2 it is gaining electron. So gaining electron is nothing but reduction potential. So remember, as the reduction potential increases, what will happen? Stability of plus 2 also increases. Correct. Now let us write the order. First one among all these which has higher reduction potential, this is. So first, whichever has higher Rp, plus 2 oxygen stability is more. So first one, Cr plus 3. They asked me to write increasing order. Last should be the maximum one. Cr plus 3 by Cr plus 2. It is less than iron. Why iron? Why did we say iron? Because it, according to the number which I see, it is further less than manganese, which is 1.5. So this is having or maximum stability of plus 2 oxidation state. This is minimum, because according to this clue which you should remember. Yes, done. So this is your question, students. So this is your 1.5 mark question. Let's come back and do the next question, that is section C question. Right, now let's come back and do the section C, that is 13th question. So from section C, you very well know each question carries 3 marks. You have to be very careful for getting that half mark. Right, so basically whenever a numerical is given to you, first let us read the numerical. Niobium crystallizes in BCC. Okay, it's a body centered cubic lattice. If the atomic radius is 143.1 picometer, calculate the density of niobium. So atomic mass is 93 U. Right, atomic mass will be given. So first of all, I have to calculate density. Right, so fine. So whenever you are starting, you will just write like this: density is equal to question mark. Done. Now first mark, first formula or first mark carries for the formula, first half mark. But density, what is the formula? Let me write density, that is denoted by rho, which is equal to Zm by A cube by Na. So let's see what we have. Na is Avogadro number, which I know. A cube, do we know A cube here? Did they give me A cube? I don't have. I can find out A cube. From where can I find out A cube? We have the formula basically, which is relating the edge length, that is for BCC, R is equal to root 3 by 4A. Here this is our A. Let us find out. What is the radius given to me? Radius is 143.1 picometer is equal to root 3 by 4. How much is A value? A I have to find out. Take this out. Cross multiply these two. I get an answer of 330.4 picometer. Now it's easy to substitute. Now let us substitute. What is Z? Z is nothing but number of atoms in the particular lattice. Here they've given BCC. For BCC, Z value is how much? It is 2. What is the molar mass given to us? They have given capital M is equal to 93 U. What is A cube? A cube is nothing but 330.4 to 3 picometer. What is Na? Na is nothing but Avogadro number, but 10 to the 23. Correct? Not minus 23, it is 23. It is not minus, wrong. Now substitute. Density is equal to 2 into 93 divided by 330.4. Done. So picometer. I am converting that picometer into centimeter, because atomic mass unit is given, so you multiply with 10 raised power of minus 10, so this becomes centimeter now. Yes, into Avogadro number 6.023 into 10 raised power of 23. So when I do solve this, I get an answer of 8.58 gram per centimeter cube. Done. This is U, that is remember grams per centimeter cube, gram per centimeter cube. Correct? Yes, done. So this is cube. So the whole thing done. So this is your sum. Now let's come back and do next one, that is the 14th question. Give reasons for the following. What did they give me? They said when benzene or 2 grams of benzene, yes, is dissolved in 25 grams of benzene. Okay, 2 grams of benzoic acid is dissolved in 25 grams of benzene. The experimentally determined molar mass is always greater than the true value. Why they said? Okay, done. So basically they're giving us a clue here only, saying that benzoic acid is dissolved in 25 grams of benzene. Nothing to solve in that. Only thing you have to remember is benzoic acid has the property of dimerizing. Okay, right? It basically dimerizes, or it associates together. So what will happen when it associates together? This is the first question, then this is the second question, and third question. So benzoic acid, what is the formula? It is, okay, let us write C6H5COOH. Now join this side, C6H5COH double bond O. Correct? Yes. So what will happen? One water molecule is released out. This water molecule is released out. Right. When they combine, what will happen? There is a formation of a hydrogen bonding between two. How does this look like? See here. Here this is oxygen, isn't it? Now here this is hydrogen. So there is a formation of hydrogen bonding between oxygen and hydrogen and oxygen. Done. Right. So what is happening? Here the molecules of benzoic acid are dimerizing. And when they combine, I said during hydrogen bonding, this molecule of water is released out. Done. And finally, where is that cleave? Exactly here. This is the bond formed, isn't it? Right. So during this process, the molecule will condense because water molecule is removed. So what will happen to the number of particles? You will write due to association. This is the word which you should write. And in the bracket, you will write dimerization. This is the form. Here only the examiner will give you half mark, or finally together 1 mark. So due to dimerization, what will happen? The number of particles get reduced. Number of particles are reduced. Done? Yes. So over, isn't it? So because of this, what will happen? Here we said 2 grams of benzoic acid is dissolved. The molar mass is always greater than the true value. Correct? Yes. So experimentally determined. Now let's come back and do the next question. What they give me? Mixture of acid, ethanol and acetone shows positive deviation, they said. Okay, here I have done one video with the positive positive deviation of Raoult's law, the negative deviation of Raoult's law. That video I have done for Raoult's law. Very careful students, please you can watch that video. I've clearly explained with different examples which will undergo positive deviation, which will undergo negative deviation, and all these. Right. So here what it give me? Mixture of ethanol and acetone shows positive deviation. Already they have given that it shows positive deviation from Raoult's law. Nothing to draw the graph and anything. Simple. So answer. Why does something show positive deviation? Suppose if it is like this, right? So this is, we have drawn the graph like this, right? So some will show positive deviation about the ideal behavior. This is what they are speaking, right? So what will happen? Ethanol and acetone are weaker, means the intermolecular forces of attraction between them are weaker. Why? Because they are, most important thing is, ethanol and acetone are non-polar in nature. First reason you can write, since ethanol and acetone are non-polar, what will happen? Intermolecular forces of attraction are weaker. Intermolecular force of attraction is weaker. When the intermolecular force of attraction is weaker, what will happen? Easily it can escape, isn't it? Right. So what will happen? Escaping forces are very weak. So escaping tendency of ethanol and acetone increases. When you mix it, it starts increases on mixing, right? So then what will happen? The vapor pressure automatically increases, isn't it? Hence vapor pressure increases. It's simple, isn't it? So this is ethanol, this is acetone. The force of attraction between them is very weak, so the bond easily breaks up. When the bond easily breaks up, they're going to vaporize. When it vaporizes on mixing, automatically the vapor pressure here Opposite direction you have one pressure, this is also one pressure, so this exerts in this way, this exerts, so automatically vapor pressure increases. This is how you're going to write the answer. Now third one, the preservation of fruits by adding concentrated sugar solution protects against bacterial action. They say the preserved fruits you have to preserve. Okay, what do? They are adding concentrated sugar solution, it seems, so which will protect against bacterial action. What is it? So basically, let us understand the concept. What is the concept? We are adding sugar solution. Which solution? Concentrated sugar solution. So you can start writing like this: concentrated sugar solution. What does it do? It protects fruits. How does it protect? Because it protects fruits from pathogens. What are the pathogens like? Pathogens like Salmonella. This is one pathogen. Or you have one more pathogen like Clostridium botulinum. Okay, these two pathogens are present in the fruits. Done. So what are we going to do? We have to break down all this particular thing, or the cell wall of this bacteria or the pathogen should shrink. Correct? So what will happen when you are adding sugar solution to this fruits? Automatically what will happen? It starts withdrawing water from, means this sugar, whatever is that, it will get inserted into the cell wall of that, and it starts sugar or salt. Let us write sugar or salt. It starts withdrawing water from where? From the fruit. It starts withdrawing water from the fruit. It starts withdrawing water from the bacterium. So now what happens is, bacterium is present on the surface of the fruit. Now you are withdrawing water, or you're pulling out water from that. Correct? Yes. So when you are withdrawing water from that, what will happen? Bacterium on the fruit loses water. Once it loses, what will happen? It starts shriveling, means it will start shrinking, isn't it? It will shrink, and finally what happens? And dies. So what will you write? The most important thing, this is due to, you will put the answer in a box. Due to osmosis, you can write the last sentence: bacteria shrivels and dies. That's it. Here you're going to get mark. 1 mark for this, 1 mark for the earlier question, and 1 more mark for the earlier question. Right, students? So this is your question. Let's come back and do the next question. Let's come back and do question number 15. What do they give us? An alcohol, that's alcohol A with the formula C4H10O on oxidation with acidified potassium dichromate gives acid B. Done. So that the formula given is C4H8O2. Done. As compound A, when dehydration with concentrated sulfuric acid at 443 Kelvin gives compound C. That is also done. Then they said treatment of C with aqueous sulfuric acid gives compound D. Formula is given to us, which is an isomer of compound A. Compound D is resistant to oxidation, but compound A can be easily oxidized. So I have to identify A, B, C and D. Name the type of isomer exhibited by A and D. Now let's start solving the question. So what did they give me? They said compound A, an alcohol A with formula C4H10O. Okay, C4. Let's write 1, 2, 3. Okay, H10O. So let me take one methyl group here, OH here. Now fill in the hydrogens. So this is 3. This has 1, this is 2, this is 3. Now count the hydrogen. C4 is done. 1 hydrogen, 3, 6, 7, 8, 9, 10. So the formula is C4H10O. This is compound A. So what did they say? They said compound A on oxidation with acidified potassium dichromate. So acidified potassium dichromate means K2Cr2O7 with sulfuric acid. This is what is called acidified potassium dichromate. So what does it do? It gives acid B. So they have already given, it gives an acid. A clue is given. So from alcohol you have to write, because it is nothing but oxidizing agent, isn't it? So what will happen? It removes hydrogen and adds oxygen to this. Now add hydrogen, add oxygen, CH3, CH, your CH3 and your COOH. This is your compound B. What is the formula they have given us? They said the acid is C4H8A, H8O2, C4, 1, 2, 3, 4. Okay, H8, 3, 6, 7, 8. Done, isn't it? It is C4, H8O2. Done. They said compound A when dehydrated with concentrated sulfuric acid. So concentrated sulfuric acid is a dehydrating agent. Done. At what temperature? At 443 Kelvin. So what does it give? It gives compound C. What is the formula? They have not given anything. So it gives compound C. This dehydrating means removing water. From where should you remove water? You have to be careful. Hydrogen, look here, hydrogen from here and OH from here will be removed. Once again, don't remove hydrogen from here and OH from here. You have to remove hydrogen from here, OH from here should be removed. So what will you get? You get CH3 carbon, and the bond whatever is here between carbon and hydrogen, that will drop here. Okay, this bond will drop here. So this becomes C double bond CH2 and this is CH3. Done. Right. This is compound C. Done. Then treatment of compound C with, what did they say? Aqueous sulfuric acid, aqueous H2SO4. It gives compound D, and they said the formula for compound D is C4H10O. This is the formula. Is it C4H10? Let us write C4, 1, 2, 3, 4. Right? Then fill in the hydrogens. CH3, CH3. This is CH3 and this is CH. Now how many? 3, 6, 9, 10. So done. One oxygen less. No, it is it 369 only, 369. So there should be one more hydrogen, which I'll write it as OH group. Done. Now what did they say? Then they said compound D, which is an isomer of A. See here, compound D is an isomer of A. Correct. So compound D is resistant to oxidation. Okay, but compound A can be easily oxidized. It is resistant to oxidation. Okay, correct. That's correct, because here it is tertiary alcohol. Tertiary alcohol, oxidation, further oxidation, it will not undergo further oxidation. Understood, isn't it? Right. So what did they ask me? I have done clearly. This is the perfect way of explaining. You will be getting complete 3 marks for this. Now, what should you write? You have to write the answers like this. They've asked A, B, C, D, no? So thus, you can write thus and start writing, name it. Compound A. What is compound A? It is 2-methyl propanol. Okay, 2-methyl propanol. Let us see whether I have written correctly or not. Compound A is 2-methyl propanol. Correct. Then what is compound B? Compound B is 2-methyl propanoic acid. Correct. Right. So right, like compound B is, your compound B, if I have to say, it is nothing but 2-methyl propanoic acid. Propanoic acid. Then compound C is nothing but 2-methyl. Compound C is 2-methyl propene. So it is 2-methyl propene. And what is compound D? Compound D, if I have to take, it is nothing but 2-methyl prop-2-ol. 2-methyl prop-2-ol. Right. So this is, let's write 2-methyl prop-2-ol. Done. So here you have to write the formulas also, because I have written here already. I am not writing it again. So the formulas to be written here, the answer. Right? Done. Fine. So next question. What did they give me? 16th question. They said, which of the following compounds will undergo faster hydrolysis reaction by SN1 mechanism? Justify your answer. So first of all, whenever SN1 mechanism is given, you have to remember this order of SN1 reaction, because I have done a mechanism also. Please watch the video for SN1 and SN2 in haloalkanes. Order for, I should not write off, order for SN1 reaction. What is order? 3 degree, greater than 2 degree, greater than 1 degree, greater than methyl halides. Okay, remember. So this is the order for SN1. Now, first important, what did they give me? They have given me 2 examples. One is benzyl chloride, one is propyl chloride, 3 carbons. So here, is there anything which is tertiary? Not there. Is there anything which is secondary? Yes, secondary halide. Let me see. 2 hydrogens, 1 ring. Correct. So this is secondary. This is primary. Primary means 2 hydrogens. This, right? So what can we write among these 2? First is benzyl. This both are same basically. If I have to say, benzyl chloride shows greater affinity towards SN1 reaction. What is the reason? We will write propyl chloride. This is a concept. What is the reason? Here only once you write this, put it in the box. Here directly you will be getting mark. But what is the reason? Let's write the reason. So important thing is this benzyl chloride. Because it shows resonance, during this process of resonance, it's going to form, right, benzyl chloride. It forms, most important thing, forms stable secondary carbocation. We are going to see how it's going to form stable secondary carbocation. So whatever carbocation it forms, it has to get stabilized, isn't it? So this gets stabilized by how? By delocalization of pi electrons. By pi electron delocalization. Right? So this is the concept. Basically the examiner wants you to write this, underline this word, stable carbocation stabilized by pi electron delocalization. If you write this, the examiner will understand, okay, this child knows the concept, and how are you going to justify? You're going to write the answer for the formation of carbocation in the question. Then what will happen? Automatically the examiner will become perfect. The examiner will understand, okay, this child knows the concept of resonance. So let us take that. So benzyl chloride, this is your benzyl chloride. Done. So CH2Cl, there's a cleavage of the bond. Then when there's a cleavage of the bond, it's going to form benzyl carbocation. So CH2 plus. This is your benzyl carbocation. Done. Yes. To this benzyl carbocation, I said it's going to show resonance because of the pi electrons. First step. Once the benzyl carbocation is done, draw the pi electrons like this. This is plus. Done. Now start shifting. This is going to shift here. So resonance double-sided arrow. What do you get? You get a double bond here. CH2, done. So because this has transferred a pi electron, this will become plus. After that, double-sided arrow. This is going to shift here. This will become double bond. After that, double-sided arrow. This bond is going to shift here. This will get plus. Correct? And because this has shifted already, we can't. Here, this is the side which gets plus. CH2. Further, this undergoes resonance. This is everything. All have shifted. The final step, it forms a resonance hybrid of all these together. You want to show the resonance hybrid like this. Double bond, CH2, overall charge, if I have to say, plus. Basically, you can write that also, plus or resonance hybrid. Okay, so this is how you're going to show. Because of this resonance, so that is the main concept, it has formed a stable secondary carbocation. Is it not secondary carbocation? This is a secondary carbocation. Here also this is secondary carbocation. Correct? Because of this, finally it is stabilized by delocalization of pi electrons. Hence we have chosen benzyl chloride. Right? So there is an OR question for this. Right? What do they give us? Let's read. A compound is formed by substitution of 2 chlorine atoms for 2 hydrogen atoms in propane. Okay, so there's a compound itself. It is formed by substitution of two chlorines. They have substituted two chlorines for two hydrogen atoms in propane. Let's take that. Let's take propane, but remember you have to substitute two hydrogens for two chlorines. 1, 2, 3, 4. 3 is propane. So take this CH3. So instead of H, now earlier it was like this, isn't it? It was like this. Now this propane, what am I doing? I am substituting with two chlorine atoms, make it CH3. This is CH, this is one chlorine, CH2, Cl. Done? Yes. And they said write the structures of the isomers possible. So for this, write the structures. And what should you do? You have to give the IUPAC name of the isomer which can exhibit enantiomerism. That is most important thing they are asking us. So I have to write the isomers. So in the first step, there are chlorine atoms here. Correct? Yes. Now, can I shift the chlorine to this carbon now? Yes, let me write. So I can shift the chlorine here. This becomes CH2, this becomes CH2Cl. One more isomer. Let me make one more. This chlorine I can shift it to this carbon. Okay, it looks like CH3. One more possibility, CHCl2. Further I can take, what can I do? I can write like tetravalent 1 CH3 here, one chlorine here, one more chlorine here, one CH3 here. Now these are the following. Now they said give the IUPAC name of the isomer which can exhibit enantiomerism. Enantiomerism means it is nothing but the mirror images should be non-superimposable. Remember that. What is enantiomerism? Actually, remember you have to note one important thing. Enantiomerism means mirror images should be non-superimposable. Non-superimposable. And it should have what? Next important, it should have chiral carbon. Chiral carbon means it should have 4 different groups. Asymmetric carbon is nothing but chiral carbon. Now among all these 4, okay, among all these 4, which one has chiral center? Let's observe. This carbon has one different group, one different group, one different group. Correct. This carbon, when I see okay, let us see here, there are 2 similar, wherever there is chlorine, you have to check that. Here 2 similar hydrogens, so it is not chiral center. When I compare this, chlorine is attached to the same carbon, not different. This carbon is not chiral, so ruled out. Now here when I see both are methyl groups, both are chlorines. Again the groups are same, isn't it? So it is not chiral center. Yes or no? This is not chiral center. So what is left out? The first one is left out. So you can take along with this condition, because you can write the following isomer will exhibit enantiomerism. Will exhibit enantiomerism. So enantiomerism means I already gave you this clue, isn't it? Write down. What is the name? CH3, C, CH2, Cl and Cl. That was the thing, isn't it? Let me cross check once. CH3, yes, that's the thing. What is the name? IUPAC name they have asked me to write. So IUPAC name is, start numbering. It is, so if I count 1, 2, 3. So it is 1, 2 dichloropropane. 1, 2 dichloropropane. Right. So let's come back and see the next question. That is your 17th question.